All right, we're back. We're on page 2 of notes 18, Calc AB. We're talking about average value. So average value comes from, it's the average y value. So average value of a function is a y value. It comes from something called the mean value theorem for integrals. I will never use that as I am doing problems because people then confuse it with the mean value theorem, which average value of a function, super important. Mean value theorem, super important. Knowing that something out there in the universe is called the mean value theorem for integrals, I think is a little less important. Could have been called the average value theorem for integrals. I feel like that would have been better. In fact, let's make that change. Let's just say average value theorem for integrals. Like, is that better? I think so. That's less ambiguous. You will find fewer problems. But anyway, here's what it calls. Here's what it says. If f is continuous on the closed interval from a to b, so continuous on a closed interval, and there exists a number c, then there exists a number c in the closed interval ab such that the integral from a to b of f of x dx, so that's the total area, that's when the slushy's all moving all over the place, is equal to f of c times b minus a. This is the rectangle, right? So this is your base, and then this, the average value, that's the average y value, is the height of the rectangle, right? So you're always just, what is that? My hand's not writing very well right now. Hold on. Height. Okay, so that's what it says. In practice, the way that you're gonna end up using it is really, I mean, there's like some stuff here that you can read. So it's the height of the rectangle. There might be more than one value of c, blah, blah, blah. In practice, the way you end up using it is this. You actually divide, right? You solve this for f of c. So you're gonna divide and you're gonna get the integral over the interval. That's how I say it all the time, and I think it's really useful. So the integral over the interval. Say it with me, integral over interval. If you can remember that, which I'm confident you can, you're gonna get these problems with no issue at all. So let's see what we can do. So the graph of f of x equals 3x squared is shown. The integral from -1/2 to 1 is shaded. Okay, so that's what we're dealing with here. This is the slushy, just kind of moving around. And what we want to do is turn off the machine and see where it settles, and the height at which it settles is the average value. So what we're going to do is the integral divided by the interval. So we're going to do -1/2 to 1 of, what is our function? 3x squared. And we're going to divide by 1 minus -1/2. That's hard to like do the math there. So 1 minus -1/2 is 3/2. So I'm going to change, and then the reciprocal of that is 2/3. So I'm going to get 2/3. So this came from, this 2/3 is just this simplified. And then we'll have x cubed from -1/2 to 1. So it's going to be 2/3. 1 and then minus -1/2 cubed is -1/8. So we get 2/3 of 8 9/8, which is 3/4, 3/4. Okay, so this is the average y value, which I almost never denote in any way. That's the average y value. So if we make a rectangle that has the exact same area as this region here, it will have a height of 3/4 because it has the same exact base. So we need to have 3/4 be the height. So now, let's see, draw the rectangle with the height, use the rectangle to estimate the value of c on the interval that generates the average value. Okay, so 3/4. I mean, I'm pretty sure, so the function is 3x squared. And if you plug 1/2 into 3x squared, you get 3/4. So actually, this is the height we need. And then if I go straight across to here, the rectangle, I guess we'll use a different color. Our rectangle is this. And then the area of that rectangle, there, the area of this rectangle is the same as the area of the full region. And isn't that a little crazy? I mean, it's like, it's a really nice theorem. I mean, it like reduces things down because sometimes like man, instead of like having all these different y values, couldn't we just have one that would give us the same result? And it's like, yeah, slow and steady wins the race, right? So your slow and steady here is 3/4. Set your machine at 3/4 and it'll just go straight across. Use 3x squared and you're like crazy. You're going all over the place. It's like a more efficient way to get your area. But we were supposed to estimate, I mean, I don't know if it's so much of I mean, I guess it's still an estimate, but it seems pretty clear that 1/2 is the value of C that we're looking for. So the average, this is the average value. The average value is a height, right? So that's your average value, it's 3/4. The base turns out to be 3/2, whatever. The area of that rectangle is the same as that giant region. And I think that 1/2 is the value on the open interval. -1/2 happens to work out, but that's one of the endpoints, so you don't want to use that. Also, it's actually really unusual. C appears to be. It's really unusual to find C. Like with the normal mean value theorem, you're all about finding C or proving that C exists or like whatever. With this one, it's way more important to actually find the average value. So it's kind of interesting, right? We're interested in like, what's the average temperature? What was the average height of the water on that day? You know, what's the average amount of something somewhere? You're interested in that value. Like what time does it coincidentally hit the average value? Like no one cares about that really. But for some reason in part C we do. So we need to figure out when 3x squared is going to equal 3/4, but that's not the hardest equation in the world to solve. And then watch me get it wrong. Now we already know the solutions, plus or minus 1/2. Therefore C is going to be 1/2. All right, so the key thing, the real like problem that was in here is this one, find the average value. So the average value was 3/4. Drawing the rectangle, huge deal, extremely useful, right? This crazy area turns out to be exactly the same area as this nice, clean rectangle. And that's what we like. We like to deal with a rectangle instead of like some crazy all over the place region. Average value is the height of that rectangle. And I'm gonna stop the video here and come back in the next one and do some problems. So I will see you there.